These are the 6 lathe tools which I'll be setting up the offsets in this video. In my previous video on the Tormach 8L lathe, I had several requests from individuals on how I set my tooling up to get accurate positioning for the job I'm working on. In this particular job, I'll be using 6 separate tools, so I'll be demonstrating how I set each of these tools up to get accurate positioning, so that my machine parts will be machined to the accurate dimensions required. Okay, I'm ready to set the tooling offsets. So the first thing, I get my piece of metal and I set the length using my gauge, and then I'll lock that in place. Okay, my first tool is my left-hand facing tool. This will be tool number 10. And the first thing I want to do, I want to face off this piece of metal very slightly. Just take off maybe 5/1000ths of an inch. After finishing this cut, it's very important that the Z position not be changed with this tool. It must be left flush with this final flat surface on the piece. This first tool will be my base tool from which all subsequent tools will be calibrated. Therefore, I will be setting the lathe X and Z coordinates to the same value as this tool coordinates. From the Tormach Offset Tool page, I first select tool number 10 and then press the reset button. I then select the appropriate picture for the left-hand facing tool. This first tool will be my base tool from which all subsequent tools will be calibrated. I then zero the Z position in the center of the screen. I then insert a 0 dimension in the Touch Z dimension block for tool number 10. You must push the Touch Z button twice or press Enter twice to record the value. Next, I need to establish an accurate X dimension or diameter for this tool. So I will first turn off a small amount off the surface of the aluminum bar to obtain a smooth, round surface from which I can measure an accurate diameter. After the surface has been turned, I move the lathe tool in the Z direction to get it clear of the aluminum bar. Once again, it's important that the X position for the lathe tool not be moved at this time. Using a precision micrometer, I then measure the diameter of the turned part. I measure the diameter to be 0.7430 inches. I then record this 0.7430 dimension in the main X dimension block, and then I record the same dimension in the X position for tool number 10 at the top of the page. Once again, I press the Touch X button or Enter twice to make sure the value is recorded. If both the X and the Z dimensions for this tool have been recorded, the green lights beside these values should be lit up. I then click on the Offsets tab at the top of the page. This takes me to a page which records the data for all the tools that will be used in this project. Notice that for tool number 10, both the X and the Z boxes have 0 values. This is because this tool was set up to be the same values as the X and Z values for the system. I will then record the description of the tool number 10 as a left-hand facing tool. Next, we will calibrate tool number 11. Tool number 10 is then removed and the right-hand facing tool number 11 is inserted into the tool holder. Tool number 11 will be aligned quite differently in this operation. It's important that the right face of the right-hand facing tool should be parallel to the surface of the turned aluminum bar. I therefore move the tool to a position where this face is close to the aluminum bar in the X direction and parallel to the turned face of the aluminum bar in the Z direction. I can then use a small metal ruler to adjust the Z position of this right-hand facing tool to adjust these two faces parallel to one another in the Z direction. I move the Z-axis back and forth until the metal ruler just touches the lathe tool, as it is held flush against the flat aluminum turned face. Once again, the Z-axis position is not changed, and we'll then record this Z value on the PC screen. Tool number 11 is then selected. The tool is then reset, and the appropriate tool picture for this right-hand facing tool is then selected. The Z dimension of 0 is then entered into the Touch Z box at the top of the screen, and the button is pressed twice to record this dimension. Do not change the Z or X dimensions in the center of the screen. These are the master values in which all future tool calibrations will be adjusted. I then move the Z-axis to position the turning tool close to the surface of the turned diameter face. I can then use a small piece of paper to move the X-axis until the paper just catches between the lathe tool and the aluminum turned surface. Some other authors have just used this position to move the X-axis inward the thickness of the paper and then record this value as the X position. However, I prefer to remove the paper and then move the lathe tool inward in the X direction until the tool just removes a feather-thin slice off the surface of the turned surface. This should be a more accurate X position for the tool. Note the small sliver of metal removed from the turned part on the tip of the tool. I then go back to the PC screen and record a value of 0.7430 inches, which is the diameter of the aluminum turned surface. I record this value in the Touch X box for tool 11 at the top of the page. The Touch X box is then clicked twice to record this value. So now my value is 0.7430 for the X dimension and 0.000 inches for the Z direction are recorded for tool number 11. I then click on the Offset Table page. Note that values are now recorded in the Z and X dimensions. Note that these dimensions are not the values entered on the previous page. These values are just the difference between the tool number 10, or the system parameters, and tool number 11. I then type in the description for this right-hand tool in the description box for tool number 11. Next, tool number 6. The 0.04 inch wide grooving tool is inserted into the tool post holder. I'll be setting up this tool in the same manner that I set up the previous tool, so that the right outside face of the grooving tool will be parallel to the front face of the turned aluminum bar. I move the grooving tool and visually align it so that it's close to the aluminum bar in the X direction, and the right face of the grooving tool is parallel to the face of the aluminum bar. I again use a small metal ruler to accurately adjust the Z position of the grooving tool parallel to the aluminum bar face. The Z position for tool number 6 is now set. It's important, once again, do not change the Z-axis position until this data has been recorded. On the PC screen, I select tool number 6, reset the tool, and select the grooving tool picture. I then record a value of 0 in the Touch Z box at the top of the page and press the Touch Z button twice to record this value. The X value for this tool is positioned in the same manner as was done for the previous tool. I position the tool close to the aluminum turned face, use a small piece of paper to get the tool close to the surface in the X direction, and then slowly increment the tool in the X direction until a small sliver of metal is removed from the surface of the aluminum bar. Once again, notice a small piece of metal removed from the surface. I then go back to the PC screen and record a value of 0.7430 inches, which is the diameter of the aluminum turned surface. I record this value in the X Touch box. This Touch X box is clicked twice to record this value. I then click on the Offset Table page. Note the values are now recorded for the X and Z dimensions. Also note that these dimensions are not the values you entered on the previous page. These values are just the difference between the tool number 10, or the system parameters, and tool number 6. I then type a description for this grooving tool in the description box. Now I need to set the X and also the Y position for this tool, but it's pretty hard because you don't have a small enough point to actually center this. So what I normally do is I replace this with a small pin. In other words, this drill is in a ER20 collet chuck. So I'll take it out and I'll replace it with this pin. Now this is an 1/8 inch diameter pin which has been turned to a perfectly fine point. I'll replace it in there, and then I can center this both X and Y. And I've already centered it off for Y, so not an issue. But I need to center it for the X position. So let me take this drill out and replace it with this. And now I already centered this height-wise, so that's all set. Now I need to center it this way. And now I want to set up my X position. So the X is this dimension, in and out. So I just want to visually get it till it's in the center. This adjustment is just a visual alignment, and I usually use a magnifying glass to accurately position the tool in the center. And so that's my position for the X dimension. On the PC screen, I select tool number 3, reset the tool, and select the drill picture. I then record a value of 0 in the Touch X box at the top of the page and press the Touch X button twice to record this value. I then remove the pointed pin from the ER20 collet chuck and reinsert the .201 inch diameter drill. I then move the drill in until it just touches the surface of the aluminum bar. I can use a small piece of paper to set this dimension, and then move the tool in an additional 0.004 of an inch to accurately set this Z dimension. I then enter the value of 0 in the Touch Z box for tool number 3 and record at this value. I then update the description of the drill tool in the offsets table. The next tool is a 1/4 inch 20 thread per inch left-hand tap. Now I could put this centering pin back inside there to align it, but I found that both of these mounts were exactly the same, so there's no need to do this. So I just assume that my X position is 0. I didn't change it from the previous setting. So my X position is 0. And now I have to set my Z position. I then move the tap in until it just touches the surface of the aluminum bar. And once again I use a piece of paper to set this dimension, and then move the tool in an additional 0.004 of an inch to accurately set this Z dimension. I then enter the value of 0 in the Touch Z box for this tool number 7 and recorded this value. I then updated the description of the tap in the offsets table. The final tool for this project is tool number 4, which is a grooving or cutoff tool. This tool is calibrated in the same manner as the previous grooving tool, with the right-hand face of the grooving tool parallel to the face of the aluminum bar. Therefore, the same procedures were followed to align this tool in both the X and Z positions as were done for the previous grooving tool. This picture shows the alignment of the tool in the X direction, which a small amount of material was removed from the surface of the bar. The X and Z values were entered into the PC screen. A value of 0 was entered for the Z position, and a value of 0.7430 was entered for the X value. These values were then saved, and the offset table was updated. Now the offsets have been set for all 6 tools. Now I need to check them to make sure everything is accurate. The one dimension that's very critical is the diameter of this small cylinder. It's supposed to be just under 1/2 inch. If it's over 1/2 inch, it won't fit. So it needs to be like 0.4997. So let me run a piece and we'll verify that to check it out. I'm just going to be running the first 2 steps to check the diameter. I'm using the aluminum piece that was left over from doing the calibration to do this first test. I just want to verify the OD diameter for the piece as it's turned. So I measured this piece and the diameter was off by like 1.5 thousandths. Instead of measuring like 0.499, it's measuring 0.5013. So I need to get down between 0.4990 and 0.4997. So I could change the software, but the software is accurate. So instead I want to change the parameters on the path pilot screen. So what I need to do here is I need to change this X number to some different value. So right now it's set at 0.9001. So I'm going to increase that 1.5 thousandths. So I'm going to change it to 0.9015. And that should make the correction I need for this part. So I just highlight the number, change it to 0.9015, and press enter to save the information. And then I run another part to verify that this change made the correction. I changed the material to brass since that's what I need to use to make these parts. And I made that change, changing that X value by 1.5 thousandths. So we'll see how that affects the overall dimension. Sorry the lathe cover was in the way when I shot this part of the video, but when I measured this piece it was exactly 0.499 inches, so exactly what I needed. The X system parameters may vary from day to day when the system boots up due to the accuracy of the X and Z sensors on the lathe when it is calibrated during setup. So the system can be tweaked as follows. To decrease the diameter of the finished piece, increase the value of X on the main system screen. To increase the diameter, reduce the value of X on the main screen. This concludes this video on the offset calibration of the 6 tools that I used in my recent brass index bearing project. The techniques that I used may vary slightly from other methods used by other operators, but they work for me. Once again, thank you for watching this video. If you have any questions, comments, or concerns, as always, please give us a call or drop us an email. We're always happy to hear from you.